Today we wanted to take this opportunity to share some details behind some exciting new research we have sponsored in conjunction with our friends at D2. As many of you may recall, way back in 2006, in response to then numerous battery-related laptop recalls from some major manufacturers, we commissioned D2 to investigate the volatility of lithium-ion batteries in laptops. And the resulting video received well over 1 million views in YouTube, along with media coverage of all types from across the world. And we continue to this day to field inquiries from media, pilots unions, safety officials on almost a monthly basis. So 7 years later, we asked D2 to revisit this issue and find out, really fundamentally, has anything changed with this situation? And maybe just coincidentally, you may have noticed just this week, NBC affiliates have picked up a story about a Virginia home that received over $40,000 in damages as a result of a fire that officials have traced back to a laptop with a recalled battery. So we feel like this is definitely still an issue, and we wanted to look into it further. By now, hopefully all of you had a chance to view the new video. If not, links are available on Tech Talk and across all of our social media accounts, and the video will serve as the basis for today's discussion. Today we'll begin with a few remarks from our CEO, Rob Chang, and then we'll hear from D2 CEO, Tony Olson. And then we'll conclude with a Q&A period. And with that, I'll turn things over to Rob. Rob?
Thanks, Corey. First off, this is our first webinar. This is a new way of communicating. I hope this turns out really well, and we have lots more webinars where we can share more of what we're doing. I think we're doing a lot of exciting things. This is one of the cool things that we're working on. I've worked with Tony for, oh God, I think it's 22 years now. And so when the laptop, when back in 2006, when Dell and Sony and so on were recalling all their computers, I talked to Tony about it, and we decided to go and try to show the public how dangerous this situation really is. And I still think, I mean, nothing's changed in the chemicals that they're using and so on. So I think that it's just as dangerous a situation now to have so much energy in a heated device. And so, and you know, the history is on our side. We made the video, and I think 1 million is just on the current U.S. I mean, in the very beginning, I think in the first month, there was 1 million views, and I think that the numbers are much bigger than that, actually. But anyhow, I'll hand it over to Tony, and you can see where we are with the video now.
Thanks, Rob, and thanks, Corey. It's hard to believe it's been 22 years. That's a long time. You know, batteries have changed a lot in 22 years. Back in the beginning, you know, kind of NiCad, nickel metal hydride, and then finally lithium-ion in the early 90s, invented by Sony as a rechargeable, finally brought out to be relatively stable to take outside the lab. But that whole instability of lithium has sort of plagued these batteries from the beginning. And I think one thing to say that's important right off the bat is, you know, we believe lithium-ion batteries are safe. There's countless millions of applications being used with them every single day. However, having said that, they do fail, and when they fail catastrophically. And that, I think, is the important part, and why we really appreciate, you know, here at D2, PC Pit Stop bringing it up again, saying, well, what's happened in the last 7 years? Unfortunately, from our investigation and the calls that we've made to various people, we really can see no changes in the battery industry. You can make an argument that things maybe even have gotten a little bit worse, in the sense that there's a higher push, more push for more power, more density, less space, so cramming more power into less space for certainly laptops, but also cell phones and other types of devices. So that whole energy density issue is getting worse. Better in the sense of more storage for energy, but worse in the sense of the containment of the power. So I think that when we ran this experiment again, if you've seen the video, the failure this time was just as catastrophic, if not more so, than the last time. To give a little bit of background on lithium, I think everybody is aware of it as being one of the main components of rechargeable batteries. Some of you may know that certain lithium compounds are actually used to treat bipolar disorder. We're not going to go down that avenue today. But other uses for lithium, metallic lithium is also an additive in rocket propellant, and lithium-6 is used in nuclear weapons. So these last two, you kind of see the strength and the volatility of this element. The benefits of lithium batteries, they have extremely high energy density, the amount of energy you can pack in a given space. They're currently about 2 times more energy dense than nickel metal hydride, and at least 4 times more energy dense than lead acid. So it's a lot of energy in a small space. Another benefit is they have very low self-discharge. So just kind of sitting by themselves, many batteries just lose power just while they're sitting there, but lithium-ion are pretty good at that. They have no memory effect, so as the battery, as you kind of drain a battery part way and recharge it, maybe half or 3/4, no problem. Where other types of battery chemistries, you have to drain them all the way or you start to diminish the battery. And one of the biggest benefits is possibly the ability to form it into different shapes and sizes to conform to different types of devices and being used in very small, strange, unusual shapes and places. So those are all fabulous. The bad news, the risks, is certainly that the chemistry is very volatile. That requires, kind of special handling, and it also requires a special circuit because it can't be overcharged or under-discharged. And so there's, in every battery pack that's inside of a laptop, there is the cells themselves. I don't recommend you do this, but if you were to see pictures of a battery pack and a laptop opened up, you'd see that there are cells inside that would more resemble the typical batteries that you're used to seeing, cylindrical kind of shapes typically. And then there is some circuit board and some circuitry that helps control charging, discharging, and then also the idea is to help some of those catastrophic situations like short circuits and things like that. So lithium batteries require all this extra capability to be packed in there to try to keep them safe. One other thing that's not commonly known, by the way, is the aging factor. I think Rob had this in an earlier article he reported on PC Pit Stop, that the life of a lithium-ion battery, the clock starts ticking as soon as it's manufactured. So if it were to sit on the shelf, or if you were to buy it and put it in your drawer, its useful life is going away. Some people argue it could be as early as 2 years. I think our practical research shows it's more like 5 years, where it starts to get to the point where it's just unuseful at that point. So I think what we're here today to talk about, though, is the danger and the fire and the explosion. There was a question that was submitted by one of the members asking, is it a hot plate it's sitting on in the video? And I think one of the first comments was to the video on YouTube is talking about that we're creating this to happen. The answer is yes. We purposefully put those batteries into the unstable state. So we initiated that, but then once that started, the reactions that followed were real. And so the batteries got into what's called thermal runaway. And that's one of the phenomena, one of the problems of lithium-ion. So I think everybody, hopefully just about everybody in the world is intelligent enough not to set their laptop on a hot plate. But what we were trying to do is, for the sake of the video and the demonstration, put it into the state in a way that we could control exactly what would happen. But there's numerous ways that can happen. If you remember back the recall that Rob was talking about in 2006, there were fires and explosions on laptop battery, and the initiation of that was actually contamination, allegedly at the Sony factory, where they were having some problem with the machine, and very tiny small shavings or dust particles of metal were getting into the chemicals that were being used for the battery. And those little metal shavings were tiny, but they were strong enough to be able to, over time, as the battery chemistry moves back and forth, charging and discharging, puncture a hole in what's called the separator between the anode and the cathode of the battery. And don't worry, I'm not going to go all propeller head on you. But once the separator started to break down, then a short circuit happened, and then that started to heat up, and it's exactly the same reaction that you see on the hot plate that we were simulating. That reaction started, and as it heated up, the short circuit started to react with the anode and the cathode. They started to heat up. One started to release oxygen, and the battery started to bulge because of the release of gas and the pressure, and it literally turns into thermal runaway in the sense that it just takes off, and once it reaches a certain point, there is no stopping that reaction. So there's a thermal runaway within a battery, and then the way the batteries are packed, you get a chain reaction where the heat from one battery and the reaction there causes the next battery to go. So just like you see in the video, first one battery goes, and then right down the line, bam, 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 until basically in that case all the batteries went. So that one was contamination. Another way that it could get into thermal runaway is through overcharging the battery. Hopefully, the idea is that the circuitry that I talked about earlier will protect that from happening. It will shut off the battery and not allow it to continue to charge, but that can also put it into that state. Another way that can happen is through damage. If the battery is physically damaged, and probably the most famous result of that one is the Chevy Volt. And what's interesting about that was that one that blew up in the junkyard, so to speak, was in a test track, and it was being subjected to crash testing. But the thing that surprised everyone is that battery, that whole car was crashed. They set it into the junkyard, and it was 3 weeks later that reaction finally got into the full runaway state, blew up, started that car on fire, and burned the adjacent car. So there's an example of damage, and then also it not really kind of showing itself for 3 weeks. And so I think that, and this is a good point maybe to interject, that the person that was commenting on the video was kind of saying that, well, we're just trying to sensationalize this, and that's not it at all. I think both PC Pit Stop and D2, if I could speak for you guys for a moment, we are all about the customer in a consumer advocacy standpoint. We're not telling people don't use lithium-ion batteries. That would be insane. They are here to stay. They're going to be a big part of our future. But what does need to happen is consumers need to be aware of what can happen, how to operate it, where are the dangers, what precautions do you need to take or measures once something starts to happen. So that's the example of damage. The other is heat, and one of the questions that's being debated heavily right now is how much heat does it take from the ambient temperature or outside of the laptop to get the batteries to go into thermal runaway. There's a lot of debate, and the numbers are kind of all over the place, anywhere from internal battery temperature, 60 degrees C, up to some people saying 175. But another example of a recent case, I think this might be the one that you were just talking about, Corey. The laptop was left on a blanket so that all the vents were closed, and allegedly, again, and so who knows what the laptop was doing. It was just sitting there, but you know how laptops can get loaded up with malware, and the processor can be taken off, and all kinds of other things can be running at full speed, even though it's not doing anything useful for you. And that laptop, that caught on fire. That battery's caught on fire. So there's an example of just it sitting in a normal situation that people wouldn't think, throwing it onto a quilt or maybe even onto a shaggy rug or something like that would cause a problem. So contamination, damage, overcharging, heat. The two other ones I think are that we've come into contact with. One is more difficult for consumers to know about, is a poor design, and that's one of the reasons we stress getting especially your replacement batteries from reputable sources. Ideally, you get them back from the manufacturer where you bought your laptop, because there are designs that come from different houses where they don't know how to properly design the protection circuitry, and we've evaluated some of those circuits, and they are bad. There's trouble there. And last but not least is actually the specification itself. Now, the specification doesn't cause the problem, but going back to what's being required by the market, people want smaller devices. They want longer battery life. One of the things that's being reported, I'm going to say allegedly, if you look at what happened in the Dreamliner, one of the agencies is reporting that the problem was the batteries were packed too tightly into the battery case, and so there was a self-heating issue in that design. So again, if the batteries are working to spec, they might be fine, but how far are they being stretched at this point? Now, to turn it around in a positive thing, they're going to be able to figure this out. But using lithium-ion batteries and replacing mechanical systems, and as well as using some carbon components and things like that, one of the big advantages of the Dreamliner is they're saying it will use 20% less fuel, and that's huge. So again, there's the positives there, but we have to make sure that we take care. There have been just, I'm not going to go through all the examples. There are, I'm sure I don't even know them all. There's so many different examples. Corey mentioned one about the house. There was one we came across recently where a girl was in a university library and her laptop started on fire. She ended up carrying the laptop out of the library because she was afraid it was going to burn the library down, which I would not recommend that. That was not a good thing to do, but she's okay. In a bigger sense, if you were to look, going back to 2004, Kyocera Wireless recalled 1 million mobile phone batteries. In 2006, Sony laptop batteries, we talked about that, somewhere between 8 and 10 million. In August of 2007, Nokia recalled 46 million batteries. So this is a real issue. More recently, the U.S. Post Office prohibits now mailing of loose lithium-ion batteries, and some airlines ban transportation now of loose lithium-ion batteries. So that's kind of the overview. There are developments happening that are going to make lithium-ion capacity go up, their capability go up, and their safety. There's more uses emerging. I think we would never have expected 7 years ago when we did that first video that lithium-ion batteries would now be used in cordless power tools and things like that. But I think what's important as these develop is that we continue to help educate consumers so that they're aware of the possibility of this catastrophic failure, and then learn how to take care, how to handle, how to choose them, the replacement batteries in the first place, how to handle them, how to maintain them and use them properly.
Tony, we've got a few more questions that were submitted in advance, and then for any attendees that are on the line, any number of ways you can get questions into Tony right now. If you want to raise your hand next to your name, I can unmute you and you can ask. If you want to send me a chat message with that question, we'll take a shot at it. This one, Tony, was, and I think we addressed this in previous research, does this problem only occur when the laptop is on battery power, or does this also occur when it is connected to the wall?
If the battery is in the unit, it has the potential of exhibiting this kind of failure, whether it's plugged in or not.
Got it. This one I believe you addressed earlier, but just to clarify, is this issue more or less likely to happen the older the laptop is, or the more it is being used, or is there a way to know whether the probability is higher or lower, and whether it might happen on your laptop?
Yeah, let me answer that question two different ways. I don't think we have a lot of data on the effects of aging either reducing or increasing this. With kind of, there's one exception that I was just reading about recently, and actually our camera guy who shot our video told me about a specific case inside of his laptop where he thought the keyboard kept dying, and he replaced the keyboard and then eventually took it into the service department and realized it was actually the battery was bulging, and the bulging battery was pushing against the keyboard and causing some keys to fail. And the reason, that's a real-world example, but if you look, you'll see more articles are emerging, more questions are coming out about people talking about battery swelling. Well, it is very likely that this is the beginning of exactly that case. If the battery's swelling, it's probably because gases are being emitted as the battery is aging and it's starting to go into that state. Now, I haven't seen a definitive answer, but it seems that that is the case. So that's not a definitive answer. I think this can occur at any point in the age of the battery, so I wouldn't feel safer at any given point. But the other answer, I think, and maybe to help with that one, is it really matters more how you handle it. I think, both physically need to be careful with it. I think that probably one of the ways that raises this, again, I wouldn't say it's likely, but if you use your laptop like a desktop where the battery's plugged in to the wall and it's just always sort of trickle charging and it's always running and it's always hot, I mean, you're kind of putting the battery in the worst possible state. Now, it's meant to do that, of course, so it shouldn't have a problem, but I mean, I would say those kind of conditions are most likely. You're promoting it, so to speak. Again, it's not likely to happen, but those are all the not favorable points. Did it answer the question?
I think so. We've got more from the audience here. At what temperature does the lithium burn when it goes into runaway?
Oh, that's a good question. I heard that the number is 600 degrees. In the first video, we tried to measure it with an infrared temperature sensor, and we measured it. It actually pegged the measurement device at, I think, 999 degrees. So we thought it was over 1,000 degrees. I'm sure the reason you can probably look up lithium, and you may remember your high school experiments where the science teacher lit usually the strip of magnesium, and it burns at 1,400 degrees or something, and throws it in the water. The reason I don't know what exactly is, it's not pure lithium, of course. It's a compound, but it's up there in the close to 1,000 degrees. One little tidbit while you're getting the next question. Lithium itself, the element lithium, is so unstable that there's no known cases of it existing in nature in its pure form. Only in a compound form with something else.
Here's your next one, Tony. The recalls mentioned were all a few years ago. Are there any more recent recalls to indicate that this continues to happen at the manufacturing level?
Well, yeah, there actually was just one. I'm not sure whose battery this was, but there was a case just a week or so ago with Apple replacement batteries for Apple laptops that had a recall because of the potential of fire and explosion. So I haven't had the chance to trace that back to see. I think it was a third-party battery. I don't think it was an Apple battery, but it was specifically made, for the Apple environment. That just like weeks ago.
Next one is, how often do these thermal runaways occur?
We don't have a good number for that, because it depends on what's reported, so to speak. I think the Consumer Product Safety Commission has like the recalls, but that you know, I don't think that is necessarily a good measure, because like this case that just happened in this house with the blanket, I mean, you could say, quote unquote, that's not the manufacturer's fault, that's not the battery manufacturer's fault. The person sort of misused it, and so, you know, you could argue it's their fault possibly. So there, you know, I don't know that we really have a good number. I think that, again, if you look at just to the spec, or you look at some of the calculations around mean time between failure, it's very unlikely with a good battery manufacturer, with a good battery pack in the circuit being used to the spec, it shouldn't happen. But there's so many different ways to get it into a bad state that I think that's the concern that we want to raise.
Next question is from Josh. Josh says, many people carry extra batteries for cell phones or laptops. Is there a danger of short-circuiting the battery and causing a thermal runaway if the battery leads come in contact with keys or other metal objects outside the device?
Well, the answer should be no. There's circuitry inside of the batteries to prevent that from happening. However, you should take care. This is another example of here's what happens if everything works according to the spec. But if there's any kind of fault in the circuitry, or if a component inside that circuit fails, shorting out the battery is absolutely one of the ways, and that's basically what happens in some of those different scenarios. It actually causes a short inside the battery. So if that short outside the battery were to be transmitted and not cut off, yeah, that can happen. Again, it's unlikely, but should take care, because the catastrophic case is that the battery takes off and blows up, not just that it fails and you need a new battery.
Next question comes from Leo. Leo asks, any additional advice for consumers beyond avoiding heat, i.e. good ventilation, avoiding used damaged batteries, and getting proper replacements?
Well, I think that you know, we'll have to bring that paper back up again, Rob and Corey. We wrote a little paper for PC Pit Stop a while back, and there's a number of do's and don'ts. And the good thing is the things that you can do to help prevent this are also the kinds of things you can do to help prolong the battery life itself, just a functional life. So, you know, kind of don't leave your battery plugged into the charger forever with the unit on and running at high temperature. You should use your device regularly. A lithium is kind of the opposite of some of the other batteries. It's use it or lose it. The more you use it on battery power, not plugged in, and kind of let it charge and discharge regularly, the better. You should shut off your device when not in use. Don't leave it in a hot environment. Don't throw it into the windshield of your car, or leave it out in the sun. Those are those are not good. This is, again, unique to lithium-ion. You should not drain the battery fully between every single charge. You remember that from nickel metal hydride. You actually want to do that. So here's a consumer education thing where one battery technology requires you to drain it all the way, or you'll end up with a memory effect and less capacity. The other one, it's not so good. You do want to occasionally have a full discharge, so not that you never want to do that. If you have to store the battery, it's best to store it in a cool place. Now here's the ideal lab thing. Putting it in a kind of like 60 to 70 degrees at a 40% charge is like perfect to keep the battery living long and in good condition. Generally, you don't want to purchase a lithium-ion battery, and just let it sit in case. I mean, if you're alternating batteries and you need it, that's different. But again, that clock is ticking for its life from the moment that you manufacture it. And you do, back to the question of the leads, you do want to be careful with static electricity, the charging circuit. So not only should the battery itself be from a reputable manufacturer, but any kind of charging circuit, make sure that that's from a reputable manufacturer, because once you plug that in, if static or some other kind of malfunction, the charger damages the battery, it's very possible it's going to damage that protection circuitry inside, and then if the battery still functions, you could be in a more vulnerable state. The other thing is, I've seen some people talk about this, and I'm probably as cheap or more cheap than anybody. Don't try to restore your worn-out batteries. If people have tried to kind of shock it or freeze it back to life, don't do that. That's very dangerous. And also, don't throw it into the garbage when you're done with it. Take it to your proper recycling center and get a new battery.
Great. I think we've knocked out the questions here, Tony. If you've got any closing comments at all.
I think that I think the message that we want to leave everybody with, and we hope that you guys will help us portray, is lithium-ion is here to stay. It's a great technology. It is one that, I was in a debate with someone earlier today. I believe in the long term, lithium-ion powered cars will overtake gasoline combustion engines. And, over the years, right now I think there's cars that can go 250 miles on a charge. We will see cars maybe in the next 10 years being able to go 1,000 miles on a charge, and eventually, hopefully in my lifetime, we'll see cars that can drive across the United States on a single charge. So the lithium-ion potential for battery is better than any other type of battery technology. Because of that density and that capability, it also is the most dangerous. And we need to help convey to people not to be afraid of it, but to actually figure out, the right way to handle and use them properly so that they can be safe. Actually, there's one other thing I want to mention when somebody's talking about carrying them around. If ever you drop your battery, you should really be leery of it. I mean, that may be if you damage a battery, you might not always be able to see it. That's probably the time to consider getting a new battery. So again, back to that physical damage. I meant to mention that one earlier. So again, these are safe, these are useful. We've got to educate people on how to do it, use them properly.
Great, thanks, Tony.
Welcome.
A couple housekeeping items here. If you have any other questions that you didn't get a chance to have answered here today, feel free to direct those to me, and I will get an answer for you.